Hi folks, this time we're going to talk about the various types of binary stars. There are four types: visual, spectroscopic, eclipsing, astrometric, and we're going to define each one of these. First off, visual binary stars. Visual binary stars are star systems where both individuals can easily be seen. Sometimes with the naked eye, sometimes with a very small telescope. You can actually, from our point of view on Earth, that you and I can actually look up and see both stars. Classic example of this is in the constellation Big Dipper. Not the end of the handle, the next little digit or the next little joint on the handle. There are two stars there. There is Alcor and Mizar. Alcor and Mizar are visual binaries. They are a binary star system, and with a little magnification of a telescope, you can actually see that there are two stars there. The next type is called spectroscopic binaries. Spectroscopic has to do with the spectrum, the visual light spectrum of the stars. Now, this is the way many star systems are detected, or multiple star systems can be easily detected. And what happens is this line, if we look at this collection of stellar spectra, absorption spectra, because it's dark lines on bright background, this red line going up and down represents zero velocity. So here's what happens. When a star is orbiting another star, so this is the larger of the two stars, here's the smaller one, and when it's behind it, the star actually, the spectrum of the first star is actually shifted a little bit towards the blue end of the spectrum. It is moving towards the star a little bit. When it is exactly next to it, the star has no motion, and they are both same distance relative to each other, and there is no Doppler shift in the stellar spectrum. When it is now on the other side of the star, the little star is on the other side of the big star, the stellar spectrum is now shifted a little bit towards the red end of the spectrum. And as it goes around and it's side by side again, it's back normal, and it's behind it again, it's shifted towards the blue. So when you're looking at the light output of a particular star, if it gives you the Fraunhofer lines or the hydrogen lines, and these lines seem to shift back and forth and back and forth over time, sometimes they're so small you can't even see them, but what this means is there is definitely something orbiting the big star and causing its spectra to shift left, right, left, right. That's called a spectroscopic binary. There's also something referred to as an eclipsing binary. An eclipse occurs when one object is in front of another. So from our vantage point on Earth, if we are here on Earth and you and I are looking at this collection of stars, as we see one star pass in front of another star, what's going to happen is it is actually the light output of the big star is going to dip. So if we look at the output, the light output or the luminosity of this star, it's going to be steady, steady, steady dip, and dips when that star is actually in front of it. If you have a flashlight, and as you hold this flashlight, light's coming out of it, and as someone walks in front of your flashlight beam to somebody a long way away looking at that flashlight beam, it's going to be steady, steady, steady. Somebody went and walked in front of it, it's going to dip, and then after they pass, it's going to be steady again. So these eclipses of one object traveling in front of another will cause these dips in light output, and they are how we determine eclipsing binaries. Fourth type of binary system is called astrometric, and astrometric binaries can be detected by gravitational wobbles in their path. So let's say that we have two stars, And over time, we plot their course. And they're not straight, but like Sirius A and Sirius B, which are two stars in the Sirius constellation, the dog star. These are actually the star Sirius in Canis Major, are actually a binary star system. And over time, each one wobbles a little bit. It doesn't travel in a nice straight line that you would expect if it had no gravitational influence, but it's got a close binary star, and that binary star is causing the path of the other star, instead of going in a straight line, to actually weave in and out and in and out a little bit due to gravitational tugging. All right, last slide in this section, because we're talking about how do we know the different properties of stars, is how do you actually weigh a star? We talked about this back when we talked about Newton's universal law of gravity. In order to find the weight of anything, in order to find its weight, mathematically out in space, you have to have two objects. Once we knew the mass of the Earth, we could then determine the weight of the moon. If you know the mass of one, you can use that information and the distance, how far away those two bodies are, to determine the mass of the other. And so you have to have two objects commonly in order to determine the mass of one or the other. Binary stars are the only stars that we have accurate masses for. A star like our sun, the only reason we know the mass of our sun is because it's not alone. It is surrounded by Mercury, Venus, the Earth, Mars, etc. And we can use the planets to help measure the mass of our star using Newton's law of gravity. So these binary stars have given us information that we can then extrapolate and take onward to other stars where we don't have their weights. And that will end this section. We're going to come back next time. And when we come back next time, we're going to talk about the exciting topic of variable stars.